Welcome to solverfy.
Hello everyone. Today we're talking more about motion in one dimension. And whenever we talk about motion in one dimension, we have to remember the important relationship between velocity, distance, and time, which is given at the very top of the upper left-hand corner, which is velocity is equal to distance divided by time. Now, in our problem, we are given that to cover a certain distance d, we travel at 60 miles per hour, and it takes some time t1. Now we travel the same distance d, but at a different velocity. So now we're going to which means we have a different time. So we'll call this time t2. We know that the average velocity for the whole trip is equal to 30 miles per hour, which is equal to the total distance covered, which is 2d, divided by the total time, which would be t1 plus t2. And now we want to find what v is for the second half of the trip. So we can start off by finding what is t1 plus t2. Well, how do we get t1 and t2? What are they equal to? Well, we take this 60. So by this first equation, we get that we multiply both sides by t1 and then divide by 60. So we know that t1 is equal to d over 60. Similarly, we manipulate this equation to get t2 is equal to d over v. So now we add these two equations. So that gives us that t1 plus t2 is equal to d over 60 plus d over v. Well, now we know what t1 plus t2 is, and we can plug it in right here. So we get that 30 is equal to 2d over, we can bring a d out from these two terms to get d times 1 over 60 plus 1 over v. And we have this new equation. Well, the d's cancel. So now we're going to multiply 1 over 60 plus 1 over v times 30, and then distribute the 30. So we have 30 over 60, which simplifies to 1/2, plus 30 over v is equal to 2. So now we're going to subtract this 1 over half from both sides. And this leads to 30 over v is equal to 1/2. We're going to multiply v times both sides and then divide by 1.5. So we get v is equal to 30 over 1.5, which is equal to 20 miles per hour. That is the average velocity for the second half of the trip, which would give us a 30 miles per hour average velocity for the entire trip. So now we want to know, well, what if this trip was going to the store and coming back? Well, when it comes to velocity, when it comes to average velocity, we care about the total displacement. And let me go ahead and clear some of this workspace. So the first part of the answer was that the average velocity for the second half of the trip was 20 miles per hour. So now we think, what if the trip was a car going to the store and coming back? Well, with velocity, we care about displacement, and displacement is the distance between your initial position, we'll call it di for d initial, the distance between this point and your final point, your d final. Well, if the final position is the initial position, so we can think of like a loop, the displacement is 0. So in the equation, v equals d over t, since the displacement is 0, this goes 0 over t, which is equal to 0. So the average velocity for a car going someplace and coming back would be 0. So now we want to know, well, what would be the average speed of going to the store and coming back? Well, speed and velocity are different because speed does not care about displacement. It just cares about total distance covered. So, hypothetical situation of a car going to the store and coming back, the displacement would be 0. However, the total distance traveled would be like folding it out and just having it like this, where we have your initial position and your final position. When it comes to speed, excuse me, and whenever it comes to speed, this problem becomes like our very initial problem, where the car just kept going. It didn't go to the store and come back. So the average speed would be the same as the average velocity from the original equation, which it was given in the problem that the average velocity for the whole trip was 30 miles per hour. So the average speed for this whole trip, going to the store and coming back, would be v is equal to 30 miles per hour, because speed does not care about displacement, only velocity.